I'm almost through marking your stuff. My target was to bring today, but I felt I'll waste my 2 hours. So I'll bring on Thursday. To make sure that I take a week, as I know, I'll also give you a week to prepare. So far you lack one thing. Some of you don't want to be serious. Someone gave me an example of semiconductor sulfuric acid. You know, like I wanted to box myself, but I still can't box myself and feel pain. There's no way I can box myself and feel enough pain. How do you do that? Sulfuric acid. In the physics, we don't talk about sulfuric acid unless even if it is about electrolysis. I don't remember where I mentioned such a word. But there was a doctor who was teaching, a professor who was teaching medicine, anatomy. So when the students came for the first time, they brought a cadaver. Anyone of you knows what a cadaver is? Dead body. So he said in medicine you don't have to, when you're a doctor you don't have to, how they say it in English, I forget, you don't have to like dislike things. They brought somebody who is injured and the wound is oozing out. So he put his finger in the anus of the dead body and then put in the mouth and tasted. So he said, "Can you do that?" They were like, "How do we do that?" But of course, this is a professor who did the same thing, and we also want people to doctors and to become professors at one time. So they dipped their fingers and tested. So after testing, he said, the other second attribute of a doctor should be observant. If you had observed very well, I put my middle finger there, but I put my second finger in the mouth. So you can imagine these guys students are, and I'm sure from that day all of them started being very observant. Did I bring anything that really required anything beyond what I teach you? But I want to rant. I bought a kettle, bought sugar, tea leaves for you to at least quench some hunger if you are in the lab. And then when you took tea, you just got tea leaves and left them in the sinks. Eh? But there is a dustbin somewhere near the door. And you take, now who do you think is going to wash your damn thing? We are breaking one rule we shouldn't eat from the lab. Our lab doesn't have chemicals. So one of you left the cup unattended to. I can know who did whatever because the camera is rolling. The camera rolls for. If you don't know how the quality of the camera is, when you go to Mwere, I put the test supervision video on, much as it was just in front. But I had that moment where I moved around according to your attendance registration. So just go on where you will see what the camera is able to see. Okay, so let's move on. The test, I can't revise the test until when we have the stuff, so be patient. Should have been today to bring the stuff. I am almost done. Left with maybe 16. Not fully, but they are marked half, but the 16 are the ones I haven't marked. The rest are marked and added. So by tomorrow, by tonight, by the way, your marks will be on the way. But we shall revise it on Thursday. Done tomorrow, I want to cover my stuff. So we did biasing. And we thought of using the potential divider to do some self-biasing. But now that all of you have been in the lab, I just want to take a few minutes to as we wait for everybody to be to talk about the lab. Both groups now we have been in the lab. You know the challenges. And so far, so good. I took through the D1 and the D2, so next time if you did D1 and you are doing D2, you won't have any problems. E1 up to E1, E2, E3, I think you are good. Those of you who did E1, E2, E1, I did it during introduction, E0, except the calculations you are doing. E2, you just take readings. Adjust, take readings, and then eventually confirm that you have a xenodite. But as I was marking a test, you still did the same thing I warned you about. You get you have a current, so I will mention more, but you have a current source of 21 milliamperes, a voltage somewhere of 21 volts, bunch of resistances in the kilos, in the kilo ohms, and then you get a current of 10 amperes, and then you underline. Which magic are you using? That the current I4 somewhere, when the only current source is giving you 21 milliamperes, you have the only voltage source of 21 volts distributed within resistances of kilo ohms, and then you get 10 amperes, you underline and hand in to me. Please, you mind about your job. Your job is to read books. So take it serious. I take my job serious. I get salary, so that's why I come early, that's why I make sure I attend. You can't do this. Because when I bring the scripts, you will understand what I'm talking about. Some even, I think, one quotes Severe too, but never put anything. So Severe, I'm not sure whether it is, I just did this. I don't know whether it's volts or... But if you get 72 amperes, you should go to jail. I am not saying that you are not supposed to fail. You can fail, but don't exhibit ignorance. And because this is common sense, that a circuit of current source of 21 milliamperes and the voltage source of 21 volts distributed in components, a bunch of resistances of kilo ohms. And you know that current is voltage over resistance. And then you get 72 probably amperes. I don't know. I will find out when I bring back. The owner will tell me. The one of sulfuric acid I know. And I understand. I understand why he put that. He's not here. Even now. So let's go to the stability. That was biasing. Let's go to stability. The reason I'm like that is that throughout my school life, if I don't know a number, I will skip. In my primary, I did an exam, finished, handed in, went to change my boards. When I came in the afternoon, that teacher, may his soul rest in peace, called me up and said, "You want to add anything?" There was a girl who used to like compete. The girl was very nice, very proud. So maybe the teacher had given her some answers and was feeling guilty. I told him, "Sir, I did what I knew. By then, I went out. I can't add because maybe I have seen him in some stuff." If he was alive, I would tell him, "Why were you doing that?" But he's left. That is primary 6. Primary 5 or 6 was another block. So if you don't know something, at least leave it blank, but don't write nonsense. Pass, say right there, pass. Don't write there, but pass. Just leave and go. 2, I just want to say these things when I'm still fresh, because we shouldn't have a lot of time on Thursday, because we just want to, by the time I read all your names to get your paper, the time will be over. The other bit is, I gave you paper. I even still had a bunch. Then someone writes, and even puts 2 lines, and writes here, and writes here. That meaningless, like you are mean into your soul. All you needed is to put up a hand, I bring you my paper. You already paid for it, or government paid for it. It's one who writes like they told them, if you write big things, you'll be punished. They write small things, and my eyes are dying slowly. And I haven't opted. I will ask Agawa how safe to get glasses. They give glasses to staff members for free. But I'm still hesitant. But I can't see near things. Far away I can see now, near things I see double star. And when you write it smaller, I see like 3 times. So I don't know what I will, how I will. So those are the few things. Me, I complain. I'm not a type who will just say, "Here are your papers." Me, I complain. I did not come here to make money under stress. And I don't think I teach for money. I teach to make sure that I add a brick to this country. If I needed money, I would be doing something else. So I don't know, which practical do you have to do for a working point? Where's and point? Those who did either E7 or E7, E15, no, E10. Which one? Which one were you doing? E10. E10 uses is a replica of part of the clipping is here. So the graphs are here in the profile, and I don't know whether I should tell you the page so that you go when you are from page 60. From page 60 to 64. Page 60. 64. The reason I'm telling you is because the oscilloscope does not bring out the waves where, the waveforms. So many people draw flowers. You have a square wave, which when you are in the lab, some of the oscilloscopes actually will give you this. You don't see this, will give you this. You don't see this, will give you this. You don't see this, you don't see this, it gives you this. You don't see this, it gives you that. And then when you pass it through a couple of resistances and capacitors, it gives you a response. And probably, let's assume that it has cut off some part like this, which does the same thing and does like this. So you find that these things are missing. And if your division per second or the frequency was low, you find someone drawing these things like this. Like fractals. I don't know whether you understand. But if you go to the book, maybe take screenshots, take some photos, then you'll be able to know what you are supposed to. Remember, practicals are an exam. Every Wednesday and Friday is an exam. But at the same time, it is a practice of what we study in theory. So it is not that I want you to go stressed, it is an exam. I am not saying that you can't go with the stuff. If it was possible, I would even give you an open book test. I say, come with your books and look. You still will fail, because to look for the answers is not easy. Not that you are getting from a friend, but from your own books, to get even the page where the stuff is. And once you get there, give me the answer that is so precise of what I want. It's not easy. So these are things I wanted to clarify, because the Wednesday group now we are going to the second round tomorrow. So I was still asking, does E3 or E7 ask about the working point? Who did E7? Does it ask you to find the load line, or which experiment is this? E3? Did you find did you draw the characteristics? Were you asked load line or working point? You sure? Got the manual here. I really don't trust students in my life. Especially what? Especially Kazuo. I really don't trust you're right. We just need to get the signal parameters. I think load line was on experiment 6, E6. That's where you are supposed to look for the load line. The reason E6 is not possible is what I don't know, because you got everything. I see I'll ask the technician why you can't run E6. So E7 is what we're going to do today. So the working point must remain fixed. We did the biasing. Biasing was, we are still looking at when we have our transistor circuit. So the working point must remain fixed. Throughout the operation of the transistor. Which one were you doing? 15. Huh? 15. Yeah, 15. So when they were doing E15, they were supposed to be adjusting the potentiometers. And then you are supposed to be keeping IB. Is it IB? At a constant value, and then you adjust the other potentiometers to adjust that. So when they would adjust here, it will also change. It's like, we want to keep this one at a fixed value, but the idea is that you must be, I don't know which word to use. You must be so keen that every time you adjust and this is changing, you take it back. You use this other potentiometer to make sure that it is at that IB as you are changing the values of, I think, IC and getting the value of the PC. And then eventually you get your output characteristics. But before I go, do you feel something, do you feel at least, I'm sorry, I should upload the test after everybody has done been in the lab, at least to know how a diode looks like. But then I found out that still it was not that helpful. It would still be, those who would do D1 and D2, and maybe E1 and E2 would have an idea about what a diode is. But the one who is doing D14, E15 will still not have an idea of what a diode is. So I think it was a drop, still okay. But what I wanted to know is, are you benefiting from the lab? Yes. Not the tea. Yes. You know, it hurts me that we would be doing one experiment at a go. When I finished the rectification, we would all have done E1. It would be nicer when all of us are doing E1. I go here, explain, and if something is not working well, I say, can I get your attention? And then I explain to them back. And now someone is doing D14, I'm explaining those of D1 and D2, and then when I reach D14, things are not moving. Are you okay? I hope so. Now, from the input characteristics, sorry, there I came to run. For the first 30 minutes, I think I will be good to run, and then I start and go officially. I draw things here, and I'm not a bad drawer, am I? Not a bad drawer. I try to draw things nicely. I draw output characteristics. I draw the axis, I put this way, and then I draw one, then I put the other, then I put the other. And then someone draws, puts this way. Then this one is better. That looks like a brand new thing. And those of you who drew with the pen, I cancelled. But I didn't cancel because of the pen. I made sure that it seems it is wrong. So if you are supposed to grow a resistor, which is like this, and because of the pen, you have already drawn the line, and then you put a resistor like this, and you circle, and you forgot about it. Because that's not a resistor. You don't draw a resistor like that. So I was just lucky that I didn't need to punish anybody for using a pen. You punished yourselves. You did such a mistake. So from the input, the reason I'm talking is I draw things. I post every video once we are done here. You got the phones. The internet is for free. When you are revising and you can't seem to get the point of what I wrote or the sentences that we have, then you can Google. You are in the era of Google. For us, we used to depend on what the lecturer gives. Even the textbooks were not accessible. Copies were not enough, but also to risk getting the textbook and take it. But whatever we would be given was enough. So from the input characteristics, and of course, if you just put here I and here is support, then you do it well, I gave you a half. You're supposed to take one. To be output characteristics, it has to be IC versus C, and you have to show me that the IB is varying like that. In electronics, when you reverse the cells, what happens? Or if you reverse the polarity, what happens? You blow stuff. That's why I'm strict. Because in electronics, when you mess up, things burn. And I think one group burned up, then they said it was the technician. One group burned up stuff. That's why I'm strict. Before you switch on E1, I want to see. Because the transformer has grown before, and that means we can't replace it there and there. So from input characteristics, we see that a small change VBE causes a large change. Causes a large change with IB. And therefore, IC, since IC is equal to beta IB. Now, to fix a stable working point, because we are under stability, we fix a stable working point, a negative current what we call negative current feedback, which we got in here, small signal parameters, is employed. By use of, we attach on the mirror. On the mirror, we attach a resistor there.
meter. So employed by use of the meter resistor. The meter resistor array. This way, the voltage gain. This way, the voltage gain will depend only on the ratio RC to RA and being dependent of the transistor parameters. We got the output characteristics. When we got the output characteristics for one of the IB constants where it starts being constant, we got the equation point, the working point. And what we are saying is that this working point can be stabilized by having a current feedback using an emitter resistor. Maybe I first draw the circuit so we visualize it is so in most of the experiments, the way they are drawn in the book is the way they are on that perspex, on that glass. So when you peep inside, you'll be able to see some components. I tried to do the improvement, but I had some challenge because I won't I'll find out later when you're almost beginning. I have at least 2 circuits in the new manual. In perspex, the way it looks in the manual is the way it is printed on the perspex. So probably the next group I'll teach, I will have finished everything so that we use the new manual and do those which are in the new manual and be able to also do the pre-pracs. The reason for pre-pracs was that before you come for a practical, you first do pre-practical. I confirm that you have knowledge of the practical and then allow you to do practical. We were dreaming really when we were doing all that stuff. How normally Africans dream when they are doing projects. We were dreaming big. But then the first hit was that apparatus was not enough, and because I knew that all the electronics had enough apparatus and the manuals, I switched back to the old practicals when I taught electronics. That's why in other labs you find it difficult to do more than 3 lab experiments. In electronics you are just refusing. I could have given you 15, but you are refusing because they are already there. They are designed, everything is available. But this new manual, they need to be designed and arranged up like the way they go. So most likely, I will put in my own money. The blackboard, I will donate it when I'm leaving. Because it hurts to donate a nice blackboard and then I go. But then also if you donate and use, it's like, does it look nice? Like you donate something, they write there donated by so and so, and then you use it. Doesn't make sense. So I will invest some money to make sure all the practicals are on the passports and see whether it can make a difference. Now on a 9, either 9 or 10. That's why I reduce them so that when I change, students don't feel bad about it. So after you have got, after you get the outline, this is experiment 6, which you can do on your own. You can go to the lab and say, I want to do this. Can you? I know you don't have it because I just gave you the experiments. I will scan it and add it just for purposes of seeing how it looks like. Get along. So the biasing, this is our transistor. Then you have the emitter, the base, the collector. So we can play around with the bias current by having the potential divider for biasing. So we have the RSC. And we are saying that for stability, we want to feedback, bring in the negative current feedback using the RIE, which is the mirror resistor. So RIE. So to complete the circuit, we have this, and then we have the VCC. Remember, especially for these and the transistors, before you put in VCC, then your transistor is useless. It's not power. Before you put VCC on a chip, for D1 and D2, and could have been also on D14, but which normally we won't be able before we do. So we have the legs. Before you put on this leg 14 for VCC as a supply and ground here, which is 0 volts, whatever is inside here is unusable. Those of you who will be doing D1 and D2. I thought I had done it, so actually tomorrow I was like, I'll be relaxing. Now I remember there's another group. Unless if that group is the one which was doing D1 and is going to do D2, then I have to explain afresh. So before you feed in the VCC, 5 volts here, especially for most of the chips, and 15 or 12 volts for most of these transistors, the transistor is just there. You have to first feed it and then you start using. It's like you have to give a soldier a gun to make sure they take your orders properly. If they don't have nothing to use, then you cannot tell them to do anything. Because they are separate. I don't know whether using the soldier is the best example I can get. So this is R1, R2, and then this feedback can be through a variable capacitor CE. Then this is RC, VCC, and this is. I enjoyed this part of the PN. How was it called? This other first one was not illustration, it was structure, yes. The structure, the diode equivalent, the circuit symbol. I enjoyed that part. I'm sorry, I may sound like a sadist, but somebody draws, and then the PP, and then he puts the arrow going out. Reverse. That means you are not attentive, and it hurts me that I try to explain. I take my time to explain. since 2012, I think 2012 is when I got a camera that can record the whole lecture. I've enjoyed because nobody can rumor about my lectures, that he says these things, nor can deny that I didn't explain. Everything is on record. And nowadays it is always online immediately. So you cannot say he didn't explain that. I'm only having trouble to remove the side top. And this one here. So if you have this path for the current, what would we call this capacitor? Or what does this capacitor do? That's what? Yes. Have you done the E1? Have you done E1? Or you are, it bypasses. You can see it is a bypass. Well, yeah, it is. These two make a filter, which you can do that purpose you are talking about. This one bypasses this other resistor. So we can say that CE is a bypass capacitor. And I still don't remember which experiment it is where they say that remove the capacitor, and to remove it means that you have, because there are two connectors here, there is a wire that you would have put here, and the wire, of course, this one will be on the ground, so you remove the wire that was connecting E7. Now, for DC voltages, when I say DC voltages, is that most of these experiments, you feed in a sinusoid or AC voltage from the function generators. Or, I think, for example, is where you need a gain, is it E15? E15, what are you supposed to get? How do you know? You will need E15. Are you supposed? Were you supposed to get the to get the amplification? That means is E7. You who are struggling from the other side with the new, with the old. You are with the IC. Which one did you do last time? Were you only two or the third one you do? You don't know his name? Mubiru. I would love to know how Mubiru looks like. I have other reasons. Does he know Marathon? Yes. So when I say for DC voltages, it's when we are feeding here a VCC, for example, we have a DC for this, and also when we are trying to adjust and feed in the DC voltage. So for DC voltages, the capacitance CE has no effect. Because the capacitor has no effect on the DC voltage. It only reacts to an AC voltage. And for AC voltage, the capacitor, the bypass capacitor CE is chosen such that one over omega CE is much less than RIE. Its reactance, this is XL. XL is one of omega C, or the, is it XL or XC? XC. XC, the capacitive reactance is equal to 1 over omega C. So this reactance, is it reactance or impedance? Impedance is the one which the Z, this is XC, but the Z, if you connected the capacitor and the resistor, then you will get the resultant of the phasor diagram. You have the current lagging, so you have, if the resistance, if this is the current in the resistor, then you have that in the capacitor, and then you have a resultant, which would be R squared plus XL or XC squared, then square root. And then it gives you the impedance. And then we would have that XC is equal to 1 over, this is 2 pi F, so this is CE. So let's just do for any capacitor C. EG, I don't know how now I can bring it back to the effect top. If we have a capacitor having capacitance of 10 microfarad, then we would have XC, the magnitude being the same as 0. 0.8 to 318 ohms. You don't ask me the numbers, it's not, we are looking at the range of the values that we can have. So we have successfully biased, stabilized our transistor circuit. And then we now need to know a few things about this circuit. One of the things from the small signal parameters was we can amplify the current or we can amplify the voltage. So before looking at either of the two, we need to know the amplification. What is it about amplification that we can get? This range here I'm putting is because of this. So amplification. All of you have subwoofers, true or false? Okay. All of you have ever heard of subwoofers, true or false? Since you want to deny that you have subwoofers, so I can change the statement and see whether that fits us. So if I'm drawing a black box to represent an amplifier, and let's start with the voltage amplifier, whereby when we have an input voltage V in, then we get an output voltage V out after we have amplified. And so the gain, which we call amplification, is equal to the ratio of the output signal
signal. The other thing I did complain about was I left a bunch of guys in the lab and said, when you are do until when you finish, I'm around. I went to my office, waited for people to say we are done. Locked the lab. For them, they just walked out. I haven't checked the video to see who walked out last. But those who were there, what were you thinking? Like leaving the lab open and you go. Like you think because I'm supernatural, I will know that you have gone. Yeah, yes. Because I brag here that I'm supernatural, let's see whether it's supernatural. That you will know that we have gone. Anyone who can tell me how, what happened? Namoko, you were in there or who was there? Who was doing Owen? Who was there? Who was there left on Friday? I don't remember. Sisi. True. You were there. And you just walked away. It's okay, you can tell me the circumstances. You finished at around? It was very scary. How? Closing. That is not closing. In the village we had this is you get wood. Instead of being this shape, then you carve here like this and put a nail through. Make sure it is flexible. So I grew up like that. We never really had one of the doors. We really never had anything like a padlock or what. That's it. And then probably we would go through inside and through the other door. The other door had a normal key. These keys here. So you would do, but when we are within inside, we use this one. So I don't know how you locked. Because you just got the thing and put the Baganda will say, you just put the door. So that's the Baganda thing, you just put the door. Anyway, please, the time to go is 7:30. Sometime back, or during our time, 6 sharp, they tell you go. Then they sign on your script, and you can come and finish later with your results. But because I normally don't jam when I'm here in the evening, and since my office can look like home, I can still watch news and whatever. So when it reaches 5, I go home, but I'm in my office. So at least I can let you finish. Then you hand in when you are done. But you don't just leave the lab. At least you could have put a background and they just put that wooden thing and walked away. So until when I said, but these people, let me go see whether they have also problems. On the lab smiling at me. So the signal, this signal we are talking about, input signal, output signal, input signal. I'm summarizing. I don't want to put a lot of words. Here, signal means that it can be voltage. So we will be talking of output voltage. It can be current. We will be talking of the output current. Or if we are producing light or producing take it in terms of the power. Thus, for this case of voltage gain, this would be the same as the output voltage over the input voltage. This one, since we are dealing with the signal being voltage, we talk of this as the voltage gain. Now, when you are amplifying at a memory level, you have to be cognizant of how much resistance you are facing when you are inputting your voltage, and then how much resistance you'll be experiencing when you are outputting your voltage. That's why we're very concerned of the input voltage, input resistance and output resistance. And when we reach the modified amplifiers called operational amplifiers, which is just simply chip with an input and output, then we also get to know a couple of things. How should be the input resistance if we want to get a perfect amplifier? And how should the output resistance be if we want to do amplification? So if we have an amplifier and we want to, it is a good subwoofer, what would be its input resistance? Would it be very high or very low? Very low. It's a nice amplifier, it's a big, it's a bomb, it booms, it's a boom subwoofer. So, does it have a low input resistance or very high input resistance? Very low. Very low. Would it have a very high output resistance or very low output resistance?
Very high.
Okay, so let's see. How we know? This is RI for input, this is R out. Let's put them. So this is there is A when it is approximately infinity, B when it is approximately 0, and then here is still A and B approximately equal to infinity or approximately equal to 0.
For inputs,
It's just a guess, so don't feel stressed. It's just a guess. We're gonna look at what it should be.
I guess that the output voltage, the output resistance is small.
A bit smaller. So for input,
For output, I say the output is small.
then for input,
The input can be large. Maybe also be small. But the output is very small.
this should be very small. Here it should be broad. Or either.
Yeah.
How do they write either in a symbol? That's not the symbol, I've just put something. Okay, so let's look at the input impedance. We say impedance because much as we are talking about resistance, but we are more comfortable if we use impedance because it can include resistors, capacitors, and inductors. That's how you should take it, that it can be either of those. So we can have the input voltage in the form of both. Okay, we can formulate it in terms of the
source in series with the resistor. So we have it as a voltage source in series with the resistor. And then we have, so this is the R source, voltage source. And then we have this output here. This is like a voltage supplying our black box. I'm saying black box, but it's a network of, when you look at the subwoofer, it's a bunch of resistances, capacitors, and if it is an advanced subwoofer, you find that it's just a bit of chips, just with the same processing unit. You just see lines being, having been printed out of the processing unit. And this is why we are drawing it in this form. And on this output, we have the load. The load may be the speaker that is producing our own music. So this is the, here, where we expect the output resistance. And then we have this as the V out. And this is the load. And this is the I2. And this is the amp. Then we have the I1. And this is the input resistance around here before entering the amplifier. Then we can have a few things to make sure that we understand how much the resistance at input should be and how much the resistance at output should be. So here, this is V out, across here. In. And then we have the resistance, input resistance here will be the whatever is in here as the voltage over the resistance, sorry, over the current. So this would be the same as the V in here over I1. Note that V in is not exactly but approximately equal to the Vs, if only and if the input resistance is much greater than the Rs. And Rs in this case is the same as the nano resistance, the nano resistance of the signal source. And when we say signal source, we say the signal could be a current source, could be a voltage source, or a power source. After all, these two can give us power. So on the onset, or logically, if this resistance Rin will be greater than this Rs, so it should be significantly large. So we cannot say input resistance for an amplifier is negligible when it is already more than the one of the current of the signal source, whether it is a voltage source or a current source. It's more than that in nano resistance. So do you get the logic now on how you should not visualize, but how you should analyze the input resistance vis-a-vis output resistance of an
an amplifier.
Yes.
So that's why the reason I brought it before is to make sure that you first wonder, how do I know it is bigger or it is smaller? From which, I mean, from here, you are able to realize that if it is going to be more than the inner resistance of the current or voltage source or power source, then it cannot be negligible. It cannot be very small. It's already bigger than that of the, and it is not just big, it's bigger, so larger than.
So if I say should be infinite, does it make sense?
Yeah, that's why I put this. That's why I put this. Because if it is bigger than, you can imagine that power source, those DC supplies in the lab. You can imagine their nano resistance. And the input resistance of an amplifier should be bigger than that. Not actually just big, but very big, bigger or larger. Larger.
So I'm understanding something that is maybe not to verify.
Yeah.
Like I'm finding it intelligent. It is infinite, maybe so that amplifier takes a very little current from the source.
Yeah, if you make an amplifier which is just chewing your current, then you'll be overspending. That's why when you use a subwoofer, just a small term of the volume, you are already shaking your head. Because it is, you know, you had your phone, already your phone was chewing the battery. And you have a nice song and you want to have an entertainment evening. You just want to make sure that you're happy. And then you now add the subwoofer to your phone. Your phone is already chewing your, or even if you are plugged in the wall, it's already chewing your car. And then you are adding on a subwoofer. If it is also going to chew your car, then it's not profitable. So that's the essence behind. So how about on the other side? Output impedance or resistance. I want you to get electronics and feel it the way we live with it. Not doing electronics here, and then when you are looking at your radio, you are like, okay, this thing. It's like, so in the weekend I tickled my colleagues from our group, our fraternity. I visited some young man in school, I didn't know, so I asked him, he's doing PCB, so I asked him, you are how many in the class who are doing PCB? He told me they are only 2. At first the circular was talking about over 200 or something A levels. So I said, so how many are doing biology? He said 60 something. How many are doing physics? Said 50 something. So the class is 50 plus. So a bunch of them are doing PCM. And I felt sorry for the young man. He's doing PCB plus some math. And some math can only give him 1 point. And he covers enough to cover this mathematics. And then he adds on 3 papers of physics. So schools advise their students to do PCM. These guys are going to be coming here to do medicine. And you find somebody in the theater, and then power fluctuates. or the oscilloscope, that thing which keeps doing like blacks out. Maybe as the patient was kicked some or one of the probes and went out. And then the guy just looks at the thing like this. Okay, can even leave you to die. Instead of checking whether everything is. So I asked colleagues in a naive way that those who are in College of Health Sciences, which of these two doctors is versatile? The versatile. I use the word versatile, and I first looked for it on the internet. And of course, people, those who tell their children to do BCM so they can get a course and the points and get a course. I mean, that's why we are suffering. There are people when the vehicle stops moving, that's it. They call their mechanic, the thing is, it is done, it can't move. Recent, I took the vehicle, it overheated, I took it, the guy, they told me they removed the thermostat because it doesn't apply in Africa. And then I said, okay, then this fella removed one of the cables for the fan. Once they put everything together and this fan was not on, I mean the cable was not on, the fan was on even when you start the engine. I've never experienced that. So they say, now it is okay, this thing was the problem. I said, fine. And of course, because the fan was blowing from onset, the cold thing was down. And they say, you can see it is now very cold. I said, fine. So I drove home. The thing was making noise. I removed the engine, put just when you put engine on, when those things are lighting, those of you are wrong, passion. Then it still was going on. So I was like, this is strange. So I almost wanted to go back to complain until when I said, okay, I know this engine of mine, I've been playing around with it. So I looked in. So one of the sockets is empty and the cable is just lying down there. So I grabbed the cable, put it back, the fan goes off. It's only supposed to be going on if you put AC or when it becomes too hot that it is needed. I didn't go to complain. He's been a mechanic for me for a long time, but maybe these days he doesn't like me anymore. Because his workmanship is going down. And of recent he told me, hello, is there any more heating on? I said, no, everything is fine. Because I'm versatile. If it is fine art, I did fine art and got an A. So when I'm drawing diagrams, I'm not bothered. If I am somewhere and if I enter a room and there are electrical stuffs, I do not get scared. I have to know this is live, this is neutral, so live is having a lot of power. If I have to bother, I have to make sure I'm insulated. But I don't think this guy can be a doctor and is useful. It's like getting a PEM guy doing simple. And when he's working on the road, they're supposed to test the soil. Know the chemistry of the soil. And then he gets a lab technician and goes, you test that soil. Say, is it okay? It is okay. That's why we have roads now being made with manure soil. You just get soil power there. But it's supposed to be marrow. Small stones, those small stones. You have to look for where to carry that. Now it is like manure soil. This, you go to where they are constructing the road. When you do like this, you make a hole there.
The hamster, the stand gates.
They disappear.
So what did they say?
The combination.
I mean, when you ask
The members, of course, I put a call, and the people from College of Health Sciences all voted PCB. But there were people who want to argue, who argued that, these days you have to pass, all of them are okay, you can't know everything. So I don't know how this will be solved, because you can't have an A-level class with all the 2 students doing PCB.
some schools they don't do it.
They don't have that combination.
Yeah, actually, no. Actually, these days, yes.
So you cannot be a medical doctor without having luggage.
They teach biology and physics at the same time.
Yes.
That's what.
Even timetabling is.
Biology and physical at some place.
I have an issue here. The teachers here are not humanity. I think they need to be more educated about careers. Because there, the interest is that you get so many A's, and then you get many students, you bring your school fees, and it's a financial issue.
Yes, that's what I mean.
And then the physics sometimes, the teachers who teach physics are a little bit boring. Okay? So students don't want to do physics because they have to practice all the other things. They are all things.
The 10 class, I get it.
Yeah, but they don't have biology practice. The game guys.
I don't
They
understand.
actually have one principle.
That's why law chose now to put
The
entry exam, because people are doing Uganda, Arabic, and entrepreneurship.
And then you get your point.
They get A. Then when they reach class, they introduce some principles of law, and they are like, what the hell is going on? First of all, they can't express themselves because they were just doing Arabic Uganda and then enter. They call it end. End was just okay. You just talk about how you can do a business and whatever. Now you're going to be a lawyer. I think this is, I'm sorry, I didn't know.
In fact, biology is not important for
Agava can verify this, but let's continue. Because Valentine wants to argue. I swear, they use this thing, how do you call it, this one? The one which you put in the ear to listen. Then there's this other one which they get, it's like this, which they put on the belly of the woman. Here how even when you run this one, they run to check on, like when they are trying to determine the gender of the kid, and they are looking at the screen. If you have no physics, you can't see nothing. Then we got X-ray. The guy goes, does an X-ray, and then he brings you a photo of the bone, and you're going to interpret it. Got no idea of what X-rays were about.
But even that's a very too far. The first year, they're going to learn physiology. There's the chemistry, the physics of neurotransmission. It's just physics, it's not.
So in a nutshell, if any one of you is doing education, becomes headmaster, please. If I ever find your school and you are doing this, because I may be a big man in the future, I may be a minister. If government changes, they can make me a minister. And I come to your school and I find that you are doing this, I will put you in. This is unfair. It's unfair. I didn't know this young man he chose the combination himself, but he was finding difficult. So when I went for the VD, I wanted to know. So I was like, how many are you? He said 2. If the class is 50 against 60, about over 60 biology, over 50 physics, but 2 doing PCB, and someone is giving an excuse of the practicals of physics, the wideness of physics, it's too much, 3 papers. Now, you just want to get things on the table or what? You don't want to have knowledge in your head.
like those of you who are doing education, some of you are being encouraged to leave alone quantum mechanics, leave alone electromagnetism, because it is not important. They want you to go and rot in a classroom. Those people down there. I did education myself, but I chopped everything. I had even wanted to do real analysis and abstract algebra. It's because the time was not there. But if you don't do electromagnetism, like those who came in here for electronics and ran away after, now you are going to be teaching electronics at all level. They have introduced electronics at A level, digital electronics, into the new curriculum. And then you go there, so you'll be saying, this is not important. Before I taught electricity and magnetism, that's how teachers used to tell students, this is not important. AC circuits, magnetism, current electricity is not important. If you can do a number in electrostatics, get two numbers in optics, which other one? Well, two numbers in optics, two numbers in electrostatics, you can get a number just somewhere. Even AC circuits, you can just get a number and gamble, you will still get your B. That kind of talk. But all the students I taught electricity and magnetism, they went and started teaching it in high school. Because I would ask them, did you do electricity? No. Magnetism? No. Current AC circuits? No. That's why I was doing for you that thing of DC and AC generator. So we take the amplifier equivalent circuit. So here we are with this source and its inner resistance, and then here we have an input resistance. So we can have the voltage source. This should be a perfect circuit of this. And then we have the RA here. This is the input resistance. And then we have this other part. This is the R out, the output resistance. And then this here. Let me first finish this other one. And then we had the load. RL. So this R out here was the one in here. So this part here this is our amplifier. So like we did with the transistor, this is the equivalent circuit. And this one is the same as AV, V in. Then we have the V out here. And this was these are the extend this one to have some levels. Am I too slow here or I increase speed? Don't they mean the same thing? When I say oh, I'm slow, I increase speed. forgive me for it, because if I don't make it nice, it will be bad forever on the video. It's okay. Actually, even if you put up part 2 is okay. If you put part 2 or 1 is okay. So don't feel bad. I don't use it. When I'm here, I can't feel nothing. So this is the V in and R in. Then we have the I1. For the end of the yeah. Then this one here. Right 2. Anything I have in record? I'm in record. 2 R L V B R in B in and V S R S. Yeah. So I've just split. I have made sure that inside here, this is the other in that I added. Other in here. And then inside here, the amplification, then V in here, and then just rule these ones as dotted lines. So V out, this V out here is the same as the voltage. So voltage is the same as the resistance times the. So the total resistance, which will be RL over the RL plus R out, then multiplied by V out is this voltage across, here. This V out is the voltage across here. Yes. But if I stretch this one and put it here, then you'll be having the total voltage as this V in times AV times B in. So this will now be like a potential divider, dividing this potential in this voltage source across R out and so to get what is going through RL, then remember for the voltage, it is that voltage of interest which goes on the top. For the current divider, if you want the current in a resistor, you make sure the resistor which repels that current to be the one on the top. So that means this will be times the AV V. And this is true when we have loaded our amplifier for loaded amp. Now V out, if we don't have a loaded amp, that means we have no don't have the load, then we will be having this one equal to AB. Then this is for one loaded. Amplified. I'm suffering like this because the suppliers supply the chalk saying it is dustless, but when you write, it has dust. You can't even write well. You must have suffered with the other lecturers who write on board and you can't even see what they are writing. The thing can't put, you see, they are very small things and they are not because of thieves. And when they bring money home and your home looks nice, you are happy. So you're also thieves. I think Uganda is corrupt because of women. You know your man is an accountant. He comes with a V8. And you know his salary is 2 million. And you say, honey, so if he's too trustworthy and as he stays in his Musugo house, you are like, but for you, others are okay. For you, what happened to you? Other husbands are okay. The husband of so and so changed the vehicle the other day. For us, when shall we ever even drive a new vehicle? We will never go to it. Out. If women of Uganda say that there is no corruption, it will not be there. If you brought things home and they say, but honey, honey, this ring you have brought me, or this necklace, how could you afford it? Me, I love you the way you are. I think we will not be corrupt. I'm serious, but they will pressure you until when you are broke, and for them they have an option. So I thought about it a long time ago, like in 2020, before COVID, and I think I'll write an article about it. Because women, they are the ones who look after children. So if they decided that there is no corruption, there is no man who can. If you bring something for your woman and she says, but honey, you are a teacher. How do you afford? How could we afford this laptop for our child? Unless if you took a loan and they may take out our land title. Then the man starts now fitting in. So this is the output. Resistance. To determine the output resistance, before I go on, you enjoy smartphones, you enjoy Bluetooth earbuds, you go around shaking your head, but do you sit down and wonder how much they go through to innovate these things? Like when you are on your phone and you are busy sliding like this, and then you sleep. Tomorrow you are watching, you are on my Wi-Fi, you are watching a recap of Man U game. Man U Arsenal, and you are smiling. Do you wonder the people who innovated this stuff, how much they put in? And for you has nothing. You are just there. You can't even want to understand what I give. I will tell you like that until when you get annoyed and you read your books. You got nothing.
We are here.
Even if your dad has something, you are just, that's your dad's stuff. It's not yours. You don't even know how they got it. Maybe they killed somebody in the head to take it.
Was killing somebody necessary.
So to determine the output resistance, R out, we replace the signal source, replace the signal source by HC nano, resistance. If it's current, and two, the load RL by a hypothetical voltage source VR. So a hypothetical, anyone of you who knows hypothetical apart from Magaba? Hypothesis, when you hear the word hypothesis, what comes to your mind? What? Prediction. So if I say I'm going to give you a hypothetical answer, so how do you say it in terms of prediction? So I'm saying prediction. Are you contacting Siri or your sister? You know Siri? There are these people who have this small thing in their houses and tells them what to do. So if you are stupid and you didn't know what does, it's like kasuku. You know kasuku? Anyone who can get me, I can get that bar. I would love to get that bar. So that when I leave it home, when I come back, it starts saying whatever was home. The parrot, yeah? Where can I get a parrot? I want to buy one. It's a bird, but it talks.
How much do you have?
This fella now is asking me how much I got. I got 1,000 shillings. Because when you say, you should, if you are selling the product, did you do economics or commerce or accounts? If you are selling the product, you set a price. And then you negotiate around that. You can't say what you got. You can say I have one shilling. That's how I treat Batembe. When they say this is for 20, I say I have 3,000. That's the only one I have. Then we negotiate up to 5,000. After all, I'm not dying to have what the was saying. So we replace, I've wrapped it, but we replace the source, and we just, if there is any nano resistance, we keep it there. The signal source, we replace the signal source by this nano resistance in there, so we got RS. Then we remove it. Then we have the amplifier. Make sure that this is symmetrical. And then we, on the other side, we replace the RL with some hypothetical, he said predictive, but something that we put something that we hope to get, or we assume we'll be able to get it. And that voltage, we call it V out. output part, and it would be this V out over I2. This would be V out over the current. So, we now have a couple of basics about amplifiers. And we know that the amplification is the output over the input. If it is the voltage amplification AV, then we have the V out over V in. If it is the one for the current, then we get the current out. For example, this would be I2 over I1. If our interest is in the current amplification, like when we had the one for the small parameters. After treating IB and VCE in terms of IB and IC and VB. I have 15 minutes to go, so I want to introduce you to the common emitter amplifier, and that should be experiment E3, the common emitter amplifier. We shall get a common collector and then the common base, and so this is E3. So we are going to look at the E3, which is the common emitter amplifier, so that when you go to the lab, common emitter amplifier. Yes.
Excuse my
You what?
when we amplify, we are causing the system to consume more energy because we are not creating any energy. So when we put in, let's say, current we are just expecting that the output will drain more from other source to produce the effect we want to produce or what.
It's like the when we use the mediameter. It's one to get from that far so that we get to some point. So if you have the mediameter, this is the kind of chocolate you will say why. Whatever the case, I'm just drawing it to get an idea, but eventually we can draw it as this is our millimeter with the pointer here and then the scale. This is the easiest way to. So we can convert this to either a nanometer or a voltmeter. If we convert it to a voltmeter, we put a multiplier. Okay? So we put a multiplier, and this multiplier is always a huge resistance, so that it does not take anything. And then it should be, if we put on a dry cell, it should be able to give us the EMF. but it is measured. It is indicating. The pointer will move, but it should not consume anything. Whereas on the other side, if we want to change it to an ammeter, we put a shunt. We divert some current. We divert some current here through a shunt, which is very small. And so it will be able to indicate for us the current going through there. Positive, this will go in that side. It's not that everything is going through the arm. So like, it's not like our current is going through the arm and that's it. The amp is helping us to make sure that we divert something to go through somewhere and give us a larger output over there. I know what you're saying. Why are we getting beautiful things out of small things? And that's why I still use the stupid example. We invest little in the soldiers, but they do amazing stuff. Like we just make sure we train them, but we don't want them to think. We just want them to do what we tell them. So if you were to make, that's why prisons now are saying that we want S4. Because if you had lawyers and they are soldiers, and you make an order, they say, is that flagrante delicto or something like that? So they start arguing with you. So you spend more time arguing with these people instead of them executing what you want. So the amplifier here, as we saw, if you are trying, this is just a box, but we are going to look at this one. Maybe can we first look at this, the common emitter, and then when we get the basics beyond this theory, because this is like kind of hypothetical. Let's look at the practical one, and then if it doesn't come out well, then we revisit the question.
Because the one for the transformer, the voltage difference or whatever.
Is understandable because you're having the coils making it. Let's now get into how it works. So let's now have, I have very few minutes, so I don't know whether, but I can draw it so that tomorrow morning once we do it. So this is experiment E3. And so we have the transistor. I don't like these people who did these supplements. And then we have the biasing. The good news is that you can access these things anytime on your web. You can even save it on your phone. So we have the class P6 in here. And then we have the output. We have the emitter common. Then we have the V in here. And the V out. And goes here. This is R1, R2, RC, and then the arrow is in this direction. I want to draw the one for experiment E3 and then we can just take a look, and after that, if we stop here, we'll be able to have, and then tomorrow morning we cover this. this is just for, as we shall now start on amplifiers, but this is what is in the practicals. You have a potentiometer here, and then you have the common VCC here, and the transistor, so we have the IB here, the ammeter, and the resistor, and the base of the transistor, and the emitter, and then across here is VB. Then we have the grounded part. Then we have here. So we are able to fire it. Then we have this is the VCE. So it's a voltmeter here. Then voltmeter here, then another there. In other words, it's not that we are inputting things in an isolated, the way it was seemingly isolated. You already have an input. Let's say if you are drawing your music from a phone, it's assumed that your phone is, connected to the supply, and then you have your subwoofer plugged to the phone. So once you adjust this potentiometer here, you can easily increase the current flowing here or decrease it, whichever way. Going up is increasing the resistance, and if you are going up here, the resistance here will be small, so the current will be bigger. But all this also is helping you also to adjust how much current is coming to bias the transistor here. So at the end of the day, you are pushing in the current, but also that is affecting what you are getting out. But you are using the same source. So at the end of the day, the reason we talk about the high input resistance is, can you allow more current to go in the, for example, in a loudspeaker, and then you get your boom boom. But on the other side here, when you are still being able to make sure you power your input to some extent. That's why when you increase your volume of the phone, then you get the sound in here fake, because you are not allowing it to make sure that whatever is taken there is good enough. I don't know whether that makes some sense. So you will be adjusting this, you read these values, you can try to set IP to a certain value by keeping on adjusting as you get different values of VCE and VBE, then you draw the input and output characteristics.
So this side here, the speaker is a problem.
Yeah, you have
The microphone, in that case, will be where?
the microphone is if you're using a microphone.
Yes,
But if you're using
we are pushing in here.
the microphone would be the one which is instead of the jack or yes, that's where your input is, because if you are too loud, that's why they say put your mic. There are these people who want to eat the mic. Those from your villages. Kanaro, are you from the village or the city boy? Doesn't matter, even if you are from Wadagaya, it is a village. Haven't you seen those people with houses, those indigenous people, and you see it is a village? I had Nopi who was staying in Mengo, and the house was like the one I was in the village. It was mud and water. Is it called mud and water or wood and water? And if you blindfolded somebody and took him in that house, say no, I'm in the village. Let's call you from here tomorrow, and then come with those who are doing E3, come with the mind of getting so that when you go to the laboratory, E3 becomes easy. And now from tomorrow, E3 is also covered. So no one will say you are teaching things which are tough. E1, E2, E3 will be covered, even E10 in a way will be covered because at least you know what diodes and know how diodes work.
Okay.
See you tomorrow.